This is section 4.6 in calculus, optimization problems, and we're looking at number 5, the measles pathogenesis, say that 10 times fast, function f of t equal negative t, parenthesis t minus 21 times t plus 1 is used to model the development of the disease, where t is measured in days and f of t represents the number of infected cells per milliliter of plasma. So my guess is they're taking blood from somebody and measuring how many infected cells there are. That's why it's measured in cells per milliliter of plasma. What is the peak infection time for the measles virus, and what is the maximum infection amount? Sketch the graph on, and I'm giving you the window here, 0 to 25 by 5, so that's the x-axis, and here's the y-axis, 0 to 1500 by 500. Label the axes with correct units. So there's a lot going on in here. And in this case, we are given the function. It's in factored form, so I'm going to look at this function where t is in time, and I'm going to multiply it out so it's easier to take the derivative. So what I did was I FOILed that, first, outer, inner, last, and then I went on ahead and simplified inside that parentheses, and now I'm going to distribute the t, and that finally gives me negative t cubed plus 20t squared plus 21t. Now it's easier to take the derivative, and that gives me negative 3t squared plus 40t plus 21. Set that equal to 0. What are we looking for? We're looking for the critical values. Maximums occur at the critical values. So now, if I set that equal to 0, unfortunately it doesn't factor, or it's not an easy one to solve. I have to use quadratic formula. So I'm using negative b plus or minus b squared minus 4ac all over 2a. You're familiar with that. I put in my a and my b and my c, and I'm getting, and you need to pause this and try to do this on your own, all right, to see if you get the same values. Watching me do it does not necessarily mean you're capable of doing it. So I'm taking this to be negative 40 plus minus square root of 1852 is what I got under here with my calculator. And then I did the plus and the minus and got 13.8, and I got the negative 0.5. Now I'm going to omit this because this is time. And I'm also looking at the function value at 13.8, so I plug that back into this. Either you can plug it into this one, or you can plug it into this one. And you should get 1470.5. That's what I got. Now, to graph this. I'm asking you to label your axes. So this was in days, and this one is in infected cells per milliliter of plasma. And if you put your function in correctly, you get this peak time at 13.8, 1470. And I wrote, because you're supposed to write your complete sentence, the peak infection time is in about 13.8 days, right? That was what we got. And the maximum infection is 1,470.5 infected cells per milliliter of plasma. All right, I'll be back for the last one.